Welcome AP Stats. In this video, I'm going to go over the first part of your lesson for the week, which is section 10.1. And there's a fair amount to cover here. We're going to cover a confidence interval and a significance test. So we're just going to start by looking at the sampling distribution of the difference in two sample proportions and then talk about the conditions. So if you look at what I've done here is create the sampling distribution for one sample proportion. We have an unbiased sample, so the sampling distribution should be centered at the true proportion. The variability, I'm just going to use the standard deviation. And the large counts condition, same thing. I'm going to use number of successes, number of failures has to be at least 10, and I'm using the true value P. For the difference, now we're talking the difference in the sample proportion should be centered at the difference between the population proportions. We're going to have to check the random condition. That's either we have independent random samples of whatever the sample sizes are, or that we have an experiment and that there was random assignment to two treatments. For variability, you'll notice I'm going to be adding the variances. So if I were to square this, that would get rid of the square root. So you'll notice I'm adding the variances and then taking the square root. We've learned this previously. You're going to have to check the 10% condition twice, once for each population. However, if you have an experiment, you do not need to check the 10% condition because there's not sampling without replacement. Large counts condition, you're going to have to check for both samples. So sample 1, sample 2, you have to have at least 10 successes and failures in each. Remember, don't use symbols. That's the advice that we're following. Now, this last part, it's not specifically in this lesson, but you can be asked to interpret confidence level, type 1 and type 2 errors, power, p-value, and context. All of that is fair game throughout these next few sections, and definitely Unit 8 and Unit 9. So let's jump in and take a look at a specific example dealing with social media. Here's the back of a book I'm using to write on. All right, so construct and interpret a confidence interval to compare two proportions. So our general format, which is on our formula sheet, is this: the statistic plus or minus a critical value times the standard deviation of the statistic, which will technically be standard error. So it's going to be the point estimate, which is what we call the statistic, plus or minus the standard error times the critical value is referred to as the margin of error. So this is what this is going to look like. You have two different groups, some critical Z value, as long as you can use a normal distribution. All right, so which gender uses Instagram more? A recent sample of 200 US females revealed 110 use Instagram regularly. A separate random sample of 150 males revealed that 60 use Instagram regularly. Construct a 95% confidence interval for the true difference in the proportions who use Instagram regularly. As I've said before, they sometimes will say construct, sometimes construct and interpret. You have to follow your 4-step process on your tests, your checks of understandings, definitely your AP exam to earn full credit. That's why I've been modeling it this entire time. So for the state step, I'm going to identify the parameters. So what I would suggest doing is pause the video, figure out what the parameters are, write them down, or verbally to yourself think about what they are, and then come back once you think you have them and check in with me. So we have PF, and this is the true proportion of US females who use, I'm just going to abbreviate Instagram, IG regularly. PM, true proportion of US males who use Instagram regularly. If this is a test or an AP exam, I'm going to write it out, but for the sake of it being a lesson, I'm not. So I have my parameters in context defined, and then I am good with the state step. I'm using 95% confidence, and I'm estimating the difference. So if I do PM minus PF. You could set it up the other way. I'll talk about how that changes things. So that's what we're trying to estimate. Okay, the plan step. All right, the plan step. We're going through our CVS. So random. Here we have a random sample of 200 US females and 150 males. So we have independent random samples of 200 and 150. As I've mentioned before, you have to include the sample sizes in there to earn credit. Variability or sampling without replacement. So 200 is less than 10% of all US females, and 150 is less than 10% of all US males. Both of those check. We're sampling without replacement, so we can calculate the standard error. Shape, we're not using any symbols. Because we don't know the true proportion for either group, we're using what happened in the sample. So for the women, 110 successes. That means 90 women did not use Instagram regularly. Both are at least 10. For the males, 60 did out of 150. That leaves the remaining 90 who did not use it regularly. This means our sampling distribution is approximately normal. So, as we've done, you have to name your procedure. Therefore, conditions met. Do A. This is now called a two proportion Z interval. Two proportion Z interval. Why two proportions? We have two samples. Okay, on to the do step. The do step is going to look like this. We have to figure out our sample proportions. So the sample proportion for males was 60 out of 150, or 40%. And for females, 110 divided by 200, or 55%. So the statistic is going to be the difference. I decided to do male minus female. Now my critical value, I'm going to get from doing inverse norm. If I have 95% of the data in the middle, I have 2.5% in each tail. That's going to give me this critical Z value of 1.96 times the standard error. So I'm taking my male proportion times its complement divided by the male sample size plus the female proportion times its complement divided by the female sample size. I'm adding the variances and taking the square root. At this point, I'd suggest just plugging this all in the calculator in one step. This minus the 1.96 times that, this plus the 1.96 times that. I would encourage you to pause the video here and plug it in and check back in and see what you get. So you end up with approximately negative 2.54 to negative 0.046. Now, I mentioned if you had set up the subtraction the opposite direction, if you had done this subtraction, your confidence interval would be positive 0.046 to positive 0.254. So it does not matter which way you set up the subtraction. Either is going to be essentially correct if you've done your work right. Now for the conclude step here, here's how this is going to look. We are 95% confident that the interval from 0.046, I went about it the wrong way, from negative 0.254 to negative 0.046 captures the true difference. And now I'm just going to kind of strip the context here. The true difference in the proportions who use Instagram regularly. I'm just going to put the way I did the subtraction in the proportions, male minus female, who use Instagram regularly. Make sure you're avoiding past tense at all costs. You're not saying who used. Anytime you go past tense, it's referring to the sample, and that would be incorrect. So that's the 4-step process that we're going to use for a 2 proportion Z interval. Not much different here. And remember, this standard error formula is on your green formula sheet. All right, I'm going to move on to the next page here on page 3. Now we're going to look at how to perform a significance test. So we're going to use the same exact data. Now we're performing a significance test, and it says, do the data, it should say, do the data provide convincing evidence of a difference in the proportion of males and females who use Twitter regularly? This idea of a difference is going to be important. So anytime you see convincing evidence, that's telling you to do a test. Oftentimes, the AP exam will not say do a significance test. You're going to be looking for the words convincing evidence, where they just have like a paragraph and then no part A, B, and C or D. That's a huge hint that this is a significance test. So my 4-step process, I'm going to start with the state. I have to do 3 things. I need to identify the parameters. I did this already on the previous page. I'm not going to do this again. I'm just going to say see previous question. All right. Then I'm going to get down to my null hypothesis. I did male minus female. We're going to assume there is no difference. The null is that really nothing's up. There is no difference. We think they're the same. Now, they said, is there a difference? That means one group could be higher or lower than the other. So this is going to be a 2-sided test, that the proportion of males minus the proportion of females is not equal to 0. They have not told us any other significant level that they want us to use, so we're going to use our default 5% level. So that's it for the state step. Going on to plan. So I could say something like this. Therefore, conditions met. No, I can't do that. I can't fully do that. Here's why, and I'm actually glad that I started going down that road. The random condition doesn't change. The 10% condition doesn't change, but the large counts condition does. And no, what am I saying? No, the large counts condition does not change. I'm thinking of a 1 proportion Z test. So I can say something like this. Conditions previously met, do a 2 proportion Z test. Notice it's a 2 proportion Z test, whereas before we did a 2 proportion Z interval. If they ask you to do a confidence interval, it's an interval. If it's a significance test, it's a test. Okay, there's no need to check conditions that have already been met. They might sometimes tell you in the body of the question, assume the conditions have been met. So you could just say conditions have been met, do a, and then name your procedure. Okay, for the do step, this is going to be something that we have not seen yet. We know from the previous question the proportion of males is 40%, the proportion of females from the sample is 55%. Because we're assuming these 2 proportions are equal, this is essentially what this is saying. The proportion of males is equal to the proportion of females who use Instagram regularly. We have to come up with a combined estimate. And the way that we do that, we use p hat combined. We take the number of successes in each group, 60 for the males, 110 for the females, and dividing them by their respective sample size. Okay, so this gives me what's called a pooled or combined estimate. So this ends up being 0.486. So overall, about 49% of the 2 samples use Instagram regularly. We only do this for a 2 proportion Z test, not a 2 proportion Z interval, because for the interval, we're not assuming that the proportions are equal. Here we have to get that common estimate because we're assuming they're the same. So here's what I know. My sampling distribution is going to look like this. It's going to be centered at 0. That's what we claim the difference is. Now, I've done male minus female. So when I subtract these two and I take the proportion of male minus the proportion of female, I'm going to get negative 0.15. So that's going to be my statistic. And this is a two-tailed test, so it could be lower than that, or it could be the opposite, the same distance away in the positive direction, or above. So my z-score is going to look like this. I'm going to take my statistic, the difference in those sample proportions minus the parameter. We claim there is no difference. Divided by, and this is on your formula sheet, I'm going to use that combined estimate, 0.486 times its complement, 0.514, times the sum of 1 over each of the sample sizes. Essentially, this is the same formula with just each numerator being 0.486, 0.514. It's just a different way of writing it. I plug this into my calculator to get my test statistic. In this case, my test statistic is about 2.779 or negative 2.78. That's fairly unusual. It's almost 3 standard deviations away from the mean. So what I need to do to get my p-value is I'm going to do normal CDF from negative infinity to this negative 2.779, comma 0.1. That's going to give me this area under the curve. I also need this area, and because it's a two-tailed test, I'm going to double that value. So I'm going to multiply that value by 2, and that's going to give me our resulting p-value, which is 0.0054. 0.0054. The only time you're doing this part, the only time you're doing this times 2, is if you have a two-tailed test. That's it, to get the p-value. All right, so we're done with the do step. Now we're on to conclude. What we're going to do here is that 3-step process, because the p-value equals 0.0054 is less than alpha equals 0.05. That's the first step. Step 2, make a decision about the null. Reject the null. That means there is convincing evidence that. Now I'm just going to strip the context again. Does this provide evidence of? Same thing. That there is a difference in the proportion of males and females who use, oh, and I forgot to switch this over. This originally said Twitter. This should say Instagram. I thought I caught them all. Who use Instagram regularly. All right. So you can see the similarities and differences between the two proportion Z interval and the two proportion Z test. So let's move on to page 4. Let's summarize this and take a look at how they are related. So confidence interval, you're going to get one of 3 scenarios. If you go to positive to a positive, that means the first proportion is bigger. Negative to a negative, the second proportion is bigger. Negative to a positive, that means there's no convincing evidence of a difference because the 0 is captured within the interval. And remember, our null hypothesis is that the difference is 0. So if that's included inside the interval, there's no convincing evidence that we have a difference. For the two proportion Z test, I went over this combined estimate, and that's just calculated by the number of combined successes divided by the combined sample size. I like how it's written different ways here. You're going to see me write it this way exclusively. You can write your hypotheses this way, whatever works for you. Make sure you define which way you do the subtraction, and you define your parameters. Just to reiterate, why are we checking these conditions? We check the random condition for two reasons. You have a random sample, so you can generalize to the population, and it needs to be unbiased, so it's centered at the true value. We check the 10% condition because we're sampling without replacement to make sure that's okay to calculate the standard deviation or the standard error. And we check the large counts condition to make sure our sampling distribution is approximately normal. So, taking what we talked about up here with how would you make a decision about a null hypothesis? So if our null hypothesis is P1 minus P2 is equal to 0, essentially that means that the two proportions are equal. If our confidence interval is positive to positive or negative to negative, that implies we reject the null because 0 is not included. So 0 is not a plausible value, so we'd have convincing evidence that they're not the same, that one of the two proportions is higher. However, if the confidence interval goes from a negative to a positive, that implies we would fail to reject the null hypothesis, and that would be because 0 is in the interval. So if we go back and take a look at what we had, our confidence interval went from negative to negative, or if you did the opposite order for the subtraction, positive to positive. So we would reject the null hypothesis because 0 is not included in this 95% confidence interval, which is exactly what we saw with this two-tailed test. We ended up rejecting the null hypothesis. So a confidence interval and a two-tailed test are going to end up in the same exact decision about your null hypothesis. So that's the bulk of this lesson. What you're going to be doing next is practicing the confidence interval and the test.